Alright guys, so first flipped lesson of Unit 3 is going to be over two sections, 3.1 and 3.2. You see that there are a lot of objectives today, but really they're all going to be pretty fast, and in fact these last two will go together, and the first two kind of go together as well. So remember we talked about in class today exponential functions. And an exponential function is going to have the form f of x equals b to the x. And so essentially b has to be a positive constant and raised to some polynomial, meaning it has variable. Okay, so our x has to be a variable. Okay, now the log function is essentially the inverse of an exponential function. It's got an equivalent exponential form. We can change between the two of them and still make our equation or our expression the same, and it's going to have the form y equals log base b of x. So we say log base b of x here. Okay, so identifying the exponent and base. Now when we have something in an exponential form and log form, they both have a base, and in this case they both have the base of b. Okay, and they both have an exponent, and the exponent for both of these is y. Okay, so they both have a base, they both have an exponent, b and y in this case. So those two were examples of the same thing. Now if we're converting between the two, like we have here, we would say that our base is 2, our exponent is 6, and 2 to the 6th equals 64. Now likewise here, we could solve this equation, which we'll look at in 3.4, but we could solve this equation easily by converting into exponential form. Since my base is 3 and my exponent is 2, that's going to equal x, so 3 squared is 9 equals x. So another way of writing this log form up there would be 2 equals log base 3 of 9. Okay, now that carries us into our next set of properties here. So we're going to need to remember these three. One easy one, anytime these two things are the same, the base and what we're trying to take the log of, it's going to be equal to 1, which again makes sense because this would just say that b to the first equals b. So that one makes sense. This b, anytime, doesn't matter what our base is, if this number is 1, what we're taking the log of is 1, it's always equal to 0, which again makes sense because we're going to have our base to the 0 power, and anything to the 0 power is 1. Okay, and then finally down here on the last one, oops, I'm sorry, we got two more. Anytime these two are the same, if we can rewrite that exponent, that would just say base to the x equals b to the x. Again, as long as b is greater than 0, meaning it's not negative, and b does not actually equal 1, because then it would be 0. And the last one, when we have an exponent to a log, if the base of the exponent and the base of the log are the same, it's just going to be x. And we could do that by saying if we switch this into log form, we'd be taking the log base b of x from the other side is equal to our exponent. We would just have the same exact thing on both sides, so that makes sense. Hey, so looking at all these, since these two are the same, we're going to say that's 1. This one doesn't matter because when this number is 1, the whole thing is 0. Here, the base of our log and the base of what we're taking the log of are the same, so that's just going to be your exponent. And here, when the base of our exponent and the base of our log are the same, that's just going to be whatever we're taking the log of, so 17. Okay, last couple things then, the common log function. Now these are just two logs that we use most popularly. They're the easiest to use. They work well with the calculator. For example, common log is anytime we have log base 10, and it is the actual log button on your calculator. This log button on your calculator does not apply to anything other than having base 10. So for example, if we saw log of 6, this would actually mean that we're taking the log base 10 of 6. And then we have what's called our natural log function, so that's going to be a log with base e, and instead of writing it log base e, we just write it as ln, so it is the ln button on your calculator. Again, this only refers to the natural log, or the log with base e. So all of these here, if we look at this, well, we know our base is 10 here. So this is log base 10 of 100. What we need to ask ourselves is 100 is 10 to what power? Well, we know it's 10 to the second, which means this is squared. Okay, don't forget ln means log base e of e to the fifth. Since these two are the same, it's 5. It's just our exponent. Again, the question we could ask here, since this is log actually base 10, that 10 million, 10 million is 10 to the 7th power. So what power is 10 million? And so that would be 7. And again, anytime that we are taking the log of 1, it's always going to be 0. No matter what our base is, that's always 0. Okay, so that is actually it for this lesson. So a trick here. What question can be asked to evaluate log base 3 of 81? You're going to write that question on a half sheet of paper and turn it in the beginning of class tomorrow. Remember, we went over a lot of things, but it was actually pretty quick, fairly basic. You guys have seen most of this before. Probably the biggest and most important things you're going to need to remember are how to convert between log and exponents. Primarily, where does your base go, where does your exponent go, and then those 4 log properties. You're definitely going to need those two in order to work with exponential and log equations. All right, we'll see you next time.